Is 3.1 linear equations in two variables. So in these next three sections, we're going to be reviewing graphs, slope, writing equation of a line, that sort of thing. So just make sure that you take your notes as you watch this video. All right, so we graph in the rectangular coordinate system, which has quadrants 1, 2, 3, 4, like in counterclockwise order. Along the horizontal axis, we have x values, and along the vertical axis, we have the y values. And that just helps us keep track of where we are. So when you plot points, you need an ordered pair, x, y. And it's always going to be in that order, x first and then y second. The point 0, 0 is called the origin. So it's right here where the two lines intersect. And here's an example where the point 1, 3 has been plotted. So the way I do it is I go over 1 to the right and then up 1, 2, 3. And I align with the 3 that's here. And then I've got my point. All right, so we're going to plot a bunch of points here. The first one is -5, 4. So I want to go to -5 on the x-axis and then up 4. So it's going to be right there. And I can label it -5, 4, so I remember. -3, -4. So -3 is to the left of 0. And then we want to go down 4 to get to -4. 2, 3 would be going over to 2 and then up 3. Oh, it's 2, -3, my bad. So 2 and then down 3. Yep, I just want to make sure I've got the right spot there because it gets a little crowded. 0, -1 is right here. And 3, 5 halves. So 5 halves is 2.5. So I'm going to go over to 3 and then up 2 and then right in between the 2 and the 3. Positive 5 halves. And there we go. So a linear equation is in the form ax plus by equals c. And a and b are not both 0. One or the other could be, but not both. So we typically work with x and y's. You'll have an x variable and a y variable. And this is what's called standard form, ax plus by equals c, which isn't that helpful for graphing, but it can be helpful for other things. And an ordered pair xy is a solution of the equation if it makes it true when you plug those values in. So the graph of a linear equation is a straight line, and every point on the line is a solution of the equation. So there's multiple solutions, and every solution of this equation is a point on the line. So like vice versa. If it's a point on the line, it's a solution. If it's a solution, it's a point on the line. So here's a graph of 2x minus 3, y equals 2x minus 3. And we want to see if the ordered pair is a solution to the equation and is the point on the line. So those are kind of asking the same thing, right? So 0, -3 is right here. So yes and yes. 3, 3, also yes. 2, -3, nope. That is not on the line. And -1, -5 is indeed on that line. So they are all solutions and all on the line. All right, so we're going to graph our first equation by plotting points. So to do that, we want to make a table in x and y values. So we get to choose what x's we want, and usually -2, -1, 0, 1, and 2 are good ones to use, but then we have to find what the y is. So I'm going to plug -2 in for x, so y is equal to 2 times -2 plus 1. Well, that's -4 plus 1, which is -3. So maybe we have a third column with the actual ordered pair. So I plug -2 in, that's my x, and I got out -3. Okay, so we're going to continue to do that. I'm going to drop the y equals this time, and I'm just going to say 2 times -1 plus 1, 2 times 0 plus 1, 2 times 1 plus 1, and 2 times 2 plus 1. So that's -2 plus 1 is -1. This is 2 plus 1, which is 3. No. That's 0 plus 1, which is 1. So 0, 1. 2 plus 1 is 3. So 1, 3. And finally, this is 5, 2, 5. So you actually only need 2 points to graph a line, but since we have all these lovely points, I might as well go ahead and plot them all. So I'm plotting my points. Now they should line up in a straight line. If they don't, then we know we have a mistake with our math. All right, so once you have them, we want to take a ruler or a straight edge and make a nice straight line with arrows on the end indicating that it keeps going. And that would be a good line. I can't use a straight edge on the iPad because it'll mess it up, but I'll give you guys rulers in class. All right, graphing vertical and horizontal lines. So vertical lines come from equations such as x equals a, so x equals a number, and horizontal lines are y equals b, where b is any number. So we want to graph x equals 4. So we just go over to where x is 4 and we make a line straight up and down. And for y equals -2, you go to where y is -2. You can make a dot there if you want, and then you make a horizontal line going through -2. And that's all there is to it. You have to remember which one is which, but after that, there's no work to be done. What is the difference between y equals 4x and y equals 4? Well, from what we just did, we know that y equals 4 is this line. But if I want to graph y equals 4x, so I'm going to choose just 3 points this time. And then I know I need to multiply them by 4, so I get -4, 0, and +4. So -1, -4, 0, 0, and then 1, 4. So we see that there's a big difference between them. They do intersect right here. They have a common point of 1, 4, which we'll later be talking about more, like about how to solve systems of equations. But yeah, they're completely different lines. One of them is a, slanted line. So this one is slanted, and then this one's horizontal. So just adding that little X on there completely changes it. Intercepts. So intercepts are just where the line crosses the X and the Y axis. So most lines have both an X and a Y intercept, but you see back here, the line y equals 4 doesn't have an x-intercept. It never crosses the x-axis. So there are some exceptions. So the x-intercept occurs when y is 0, and the y-intercept occurs when x is 0. And to find intercepts, you have to plug 0 into one and find the other. So for example, if I want the x-intercept of this example, then I need to plug 0 into y. And I get 2x equals 8, so x equals 4. Now, very important, an intercept is actually a coordinate, an xy coordinate, where the x value here is 4 and then y is 0. That's what we plugged in, right? And then the y-intercept is where x is 0. So it'll be 2 times 0 plus y equals 8. And that's just 0, so y equals 8. And the coordinate would be 0, 8. So the algebra for these are generally pretty easy because one term is just going to be 0. All right, so I can graph this. We got the point 4, 0, and 0, 8 is kind of off the grid here, but that's okay. And then I draw my line through the 2 points. Kind of missed down there. That's why we want to use a ruler. But you get the idea. All right, let's do another example. I'm going to start putting make x equal to 0, finding the y-intercept. So I get 3 times 0 plus y equals 12, which is just y equals 12, or 0, 12. I keep picking stuff that's off the grid here, so it's like 8, 9, 10, 11, 12. It's way up here. And y equals 0. 3x plus 0 equals 12. It's just 3x equals 12, so x equals 4. And we get the point 4, 0 again, and then we can draw our line. All right, so that's it for that, and then you have this homework assignment to do to practice that. All right, now we're going to talk about slope. So slope is kind of a term that you're familiar with. If you've ever gone skiing, then you have a ski slope, and the steeper it is, the faster you'll go down the hill. There's also slope of a roof, slope of a sidewalk or a ramp. So slope comes up in daily life all the time. And what it is the change in y, or the vertical change, over the change in x. So if you think of a staircase, we're going up and we're going over, up and over, up and over. And how fast we do that is the slope. It's the rate of change between points. And we have a formula before it, which you might have used before, the rise over run, or y2 minus y1 over y2 over x2 minus x1. X2 and x1 can't equal each other, or you end up with an undefined slope. All right, so we already talked about the standard form of an equation. Grab my highlighter, but it's not always the most useful. So sometimes we like to use the slope-intercept form. And then my favorite is the slope-intercept form is my favorite, because it gives you the slope and the intercept, and from those you can just go ahead and graph it. So let me show you how to do that. It's much easier than using a table. So any line that's written in the slope-intercept form is super easy to graph. So first thing is I'm going to take the y-intercept, and that's really the point 0, 1. Because if we plug 0 in for x, then that's gone. Here, let me actually show you. You don't have to do this each time, but just so we see it, if we want the y-intercept, we plug 0 in for x, so y equals 2/5 times 0, so y equals 1. So that gives you the point 0, 1. That's your first point to plot. So it's always going to be that constant that's added without the x. And then I'm going to use the slope, the rise over run. 2/5 means I'm going up by 2, 1, 2, and then over 5. And when I do that, I land at the point 5, 3, it looks like. So if it's a positive slope, okay, and then of course you can take your ruler and draw the line. So if it's a positive slope, then you go up and then right. For negative slopes, go down and then left. What else was I gonna say here? Oh, okay, so if you get a slope, if m is just equal to 2, then you can write that as 2 over 1. So you're going up 2 and over 1. I assume we have some more practice. Yeah, so here's another example. We're going to start at the y-intercept. That's 0, 2. And then I want to go down 3 and over 1. Oh, I wrote to the left, didn't I? I better fix that. So I saw that when I did that, I end up with a positive slope. Which, it's being difficult. I messed this up. Okay, so cross this out and put right. Right for both. Down and to the right. Sorry about that. So negative slope is when you slant down from left to right. So if I plotted it where I told you guys a minute ago, down and to the right, then we'd end up with a positive slope, and we don't want that. We have a -3 for the slope. C is not in the right form yet, but then we can solve it for y, which we practiced earlier. So if I add this 2x over, I get 5y equals, now instead of writing -16 plus 2x, I'm going to write 2x minus 16 because I want it in that slope-intercept form. And then we divide each one by 5. 16 over 5, it might be helpful to make that a fraction. It's 3.2. So I'm starting at -3.2, so we kind of have to guess where that is. And I'm going up to 1, 2, and over to 5 because it's positive. Up and over for positive. And then just draw my line. So with fractions, we just do the best we can with what we got. All right, so that means 3.2 homework. I'll give you some practice with that. All right, next we need to learn how to write the equation of the line given whatever information is given. So these first three are the easiest ones. If you're given the y-intercept and the slope, then you can just go right ahead and write it as 2/5 x minus 3. B would be -1/4 x plus 5. And C would just be -3x. So that's the easiest case. The next case would be when you don't know what the slope is because you're given 2 points instead of the point and the slope. So then one option is to use this point slope form of the equation to help you with these, and you can see that it's just a manipulation of the slope formula. If I take both sides and multiply by x minus x1, I end up with this equation. So it's just the slope formula kind of mixed around a bit. So some people like using that to find equations of lines. I pretty much just use this one for everything. So it's a nice review of all of our lines. All right, so find the equation of a slope of -2, and it has to have this point. All right, so what we want to do is plug that point in. This is an x and this is a y. So that would be 7 equals, then slope is -2. The x value is 1, and the only thing we don't know is b. So we need to solve for b. So that's 7 equals -2 plus b. I add the 2, and I get that my y-intercept is 9. So now I know my equation is -2x plus 9. Okay, and we get a whole bunch of, oh my, whole bunch of practice here. All right, this time we have a slope and we know a point. Same thing, we have to find the y-intercept. All right, so we're gonna plug in the y value, which is 1, slope 2/3, my x is 4, and all I have to find is b. So this is 1 equals 8/3 plus b, and I'll use my calculator to figure out what 1 minus 8/3 is. All right, my calculator says that it's -5/3. So b equals -5/3. And finally, we just have to write down the equation. So 2/3 x minus 5/3. Okay, another slope and point. So 3, it might help to label these. 3 equals -1/2 times 5 plus b. 3 equals -5/2 plus b. Add that over to both sides. That's why we have to be really good with our algebra, because it just keeps coming up. And I got 5.5. You can make it, keep it a fraction if you want, 11/2. It doesn't matter to me. Just as long as you finish it off by writing the actual equation down. All right, this time we're given 2 points and no other information, so we have to actually find the slope. So if we label these x1, y1, x2, y2, I subtract -5 minus 0 over -4 minus 4. So that's -5 over -8, which makes it +5 over 8. And now we're going to do what we did for the last 2 or 3 examples, but it doesn't matter which point you use. So I'll use 4, 0, that seems easier. So 0 equals 5/8 times 4 plus b. So this is 5/2. So 0 equals 5/2 plus b, and then subtract it on both sides. So b is -5 over 2. And we still don't know what our y-intercept is because it wasn't given. So, oh no, that is the y-intercept. My bad. We have the slope. Okay. We got everything we need then. We have the slope and the y-intercept. Y equals 5/8 x minus 5/2. All right. Ooh, horizontal line. Those are the easy ones. So horizontal, that relates to y. So I'm going to grab the y value. It's just y equals -3. Vertical lines relate to the x value. So it's just x equals 2. And undefined slope is also vertical. So again, I look for my x value, and it's just x equals 6. It ends up undefined because all the x values equal 6, and if you do 6 minus 6, you're dividing by 0. So you can remember that, or just remember that those are vertical lines with undefined slope. All right, parallel and perpendicular. So this just means they have the same slope. Perpendicular means they have the negative reciprocal slope. And I'll talk about what that means when I get there. So first we have to find the slope of the line given. And the easiest way to do that is to solve for y. So if we subtract 2x, we get 3y equals negative 2x minus 6. So notice I'm writing the x first. And then dividing by 3, we get negative 2/3 x minus 2. So my slope, my m, is negative 2/3. And it has to go through this point. So we want to plug that point in and find our b. So that's negative 8/3. So b is going to be 4 plus 8/3 because we have to add the 8/3 on both sides. I'm using my calculator and I got 20/3. This one you probably don't want to put in as a decimal because it's a repeating decimal, so it wouldn't be an exact answer if you did the decimal form. If you're not sure how to get it into a fraction, just let me know and I can show you how to do that in the calculator. All right, this happens to be the same equation, which is useful. We know that the slope is negative 2/3 of that. The slope of a line perpendicular to it, so I'll call this M1, is going to be flipping these around and then changing the sign. So it's positive 3/2. So we do the same thing, but this time it's 3/2 times 4. That's 12 over 2, so 4 equals 6 plus b. Subtract 6. All right, so b is negative 2, so it's y equals 3/2 x minus 2. Find an equation of the line graphed and then write it in standard form. Okay, so that's the form, that's the ax plus by equals c. And then we want to find an equation perpendicular to it and graph that. So what we're looking for here is the slope and the y-intercept. So it's crossing the y-axis right here. It looks like it's about 3.5. And then the slope, for the slope you want to find two exact points. So the two that are plotted there would work. And if we make a little like triangle with them, then we can, it's a little easier to count. We want the rise over the run. So it's going from 2 to 5. So the rise equals 3. And the run, this is -1. It's going from -1 to 3. So that's a difference of 4, right? Be 1, 2, 3, 4. So rise over run, which is slope, is 3/4. So a line perpendicular to it would have a slope of -4/3. And it's going through 0, 4, which is convenient because that's the y-intercept. So -4/3 x plus 4 is the line perpendicular to it. And then the equation of the line graphed is y equals positive 3/4 x plus 3.5. Oh wait, that's not 3.5 because this is 3, so this is 2.75. You have to watch how they label things because it's not always what you expect. Yep, and then I have to just change this to 2.75. because it's right in between 2.5 and 3. Okay, now we're writing the equation of a line graph, and oh, you know, I ignored the standard form. It's not very useful, so yeah, we won't worry about that. And now we want it parallel and going through 0, 1. So parallel means same slope. All right, so this line, this is going -1, -2, -3, -4. It looks like it's crossing right at -1/2. So B equals -0.5. And the slope, if I make my little triangle, it's going down. Actually, I should probably draw it a little differently. It's going down 1 and then to the right, however many that is. That's how we usually think of it when we draw them. If you went up and left, that's still a negative slope. So it's going down 1, and then this is -4. This is 1, 2, 3. It looks like it's 7. So M is -1/7. So the equation is -1/7 x minus 0.5 for the one drawn, and then the one parallel to it would be y equals -1/7 x plus 1. The 1 coming from the y-intercept, the slope, they have to have the same slope. So if I graph that, I would be plotting 0.01 and then going, yeah, if I try to go over 7, I'm going to be on the same. So it's kind of sloppy, but it's going to be parallel because it'll have the same slope. All right, applications. A rock is dropped from the top of a 400-foot building. After 1 second, the rock is traveling 32 feet per second. So that's kind of like a point, 1 and 32. And after 3, it's traveling 96, so 396. So write an equation that relates time to rate. So we have 2 points. We want to find our slope, 96 minus 32 over 3 minus 1. Let's see what that is. We got 64 over 2, so it has a slope of 32. And then we just need the y-intercept. So we can use either point. I'm going to use the 32, 1. All right, so it looks like B equals 0. Because 32 times 1 is 32, and then you subtract. So we get the line y equals 32x plus 0. And you don't have to write plus 0. Use the equation to determine the rate of travel of the rock 4 seconds. I think this is supposed to say after it was dropped. So we just want to plug in 4. Looks like it's 128. And that's in feet per second. The number of people employed by the United States as registered nurses was 2,711 in 2012. By 2022, this number is expected to rise to 38,000. Let Y be the number of registered nurses in thousands employed by the United States in the year X, where X equals 0 is 2012. So if 0 relates to 2012, then what number relates to 2022? So you can just subtract that, right? So 10. So this is your X equals 0, X equals 10. So the 2 points given then are 0, 27, 11, which is the y-intercept, and then 10, 32, 38. So using those 2 points, we can find our slope. So 32, 38 minus 27, 11. And keep in mind that when you're, going through these videos, you can always pause, rewind, or play it on a slower rate if I'm going too fast. Okay, so the equation then would be 52.7x and plus 2711. There might have been, okay, so we're going to use that equation to estimate number of nurses in 2018. So 2018 relates to X being 6, right? Because it's 6 years from 2012. So we're going to plug 6 in. 52.7 times 6, and then plus, I forget what that number was, 2711. All right, so my calculator tells me that that's about 3,027 nurses. There's a 0.2, but we can't have part of a nurse, so I'm just going to round it to 3027. And then you have this homework to work on to practice these. So jot down any questions you have and ask me in class, and I'll see you then.